So the first radical reaction that we're going to look at is the free radical addition of HX to alkenes. When you carry out this reaction, the product that is formed is not one that you would expect from your previous experience. Starting with 1-butene, adding HBr in the presence of peroxides and either shining light or heating it, the product is 1-bromobutane. The product that you're familiar with forming would be 2-bromobutane. So this is a complementary method for adding HBr to an alkene. You might remember that we have seen complementary reactions when we're forming alcohols from alkenes. So the mechanism begins by cleaving the peroxide bond, either using light or heat. So one electron from the bond goes to one oxygen, forms a radical. The other one also forms a radical on the other oxygen. I'm just going to show the rest of the mechanism with just one free radical, but the other one would also be carrying out the reaction. So, this oxygen is an electron deficient species. It would really like to react with something else that has one electron. It turns out that OH bonds are very strong. And so, what happens is the oxygen and its lone pair of electrons is going to form a bond with a hydrogen, which has one electron that it's getting from the sigma bond between the H and the Br. Meanwhile, the other electron in the bond ends up on the bromine, so that what you form is an ROH plus a bromine radical. It is the bromine radical now that's going to react further. So now the bromine radical is an electron deficient species, and it will react with the most available set of electrons, in this case the pi electrons, except it's not going to react with both of them. It's only going to react with one. So one of the electrons in the pi bond is going to form a sigma bond with the one electron on the bromine. The other electron in the pi bond is going to go to the carbon that doesn't do the bonding. And I'm not good at drawing these things. There's my half arrow. So that I can form two possible products at this stage. One of them will look like this, or I could form that product. This product is favored because the free radical is better stabilized by hyperconjugation. So that product, or that intermediate, then will react with another HBr, and carbon-hydrogen bonds are very strong. So this free radical on the carbon reacts with the hydrogen and one electron, and one electron goes to the bromine. So now I get the final product and a bromine radical. The bromine radical starts the process all over again. Remember, when you're carrying out a reaction, you're not doing just one molecule. There is a lot of HBr. There is a lot of alkene. So you might be interested in how does the reaction stop? Well, the reaction will stop whenever you have two free radicals that combine. So for instance, if a bromine radical encounters one of the carbon radicals, the reaction will stop because now there are no more radicals. Bromine could encounter another bromine radical and form Br2. When you carry out this reaction, you want to keep the number of radicals low because you don't want to have a lot of free radicals running around because they could start to encounter one another and stop the reaction. This whole process is called a radical chain reaction. In a radical chain reaction, there are three distinct steps. There is an initiation, there's a propagation, and there is a termination. You can go back through the slides now and see which of these reactions falls under which general category. So the initiation, for instance, was when the first peroxide free radical reacted with HBr. That was an initiation step. Once you got the bromine radical, then you entered the propagation stage, where the bromine radical was reacting with the alkene. And then the alkene, the product of that reaction, then reacted with another HBr to get a bromine radical. So that whole previous sequence of steps were propagation steps. Termination steps are when I have, for instance, a bromine radical reacting with a bromine radical, so that there are no more radicals present. So this is, once again, a complementary method to adding HX to an alkene without peroxides. So you have to remember that if you are trying to form this compound you have to specify that I am reacting it with HCl in the presence of peroxides. If not, if you just react it with HCl and just the normal solvent ether, you get a different product.